If you read frontline memoirs from the Second World War carefully, you will notice a strange contradiction. Soldiers frequently describe eating hot meals under conditions where open fires would have been, well, suicidal. No smoke columns, no visible flames, no glowing embers at night. Yet food was heated, rations were warmed, and in some cases even basic cooking was done. This was not exaggeration or luck. It was the result of a little-known field device and method often referred to by veterans simply as the heat rack, a system designed to cook and heat food without producing open flame, smoke, or light. It was born out of necessity, refined by engineers, and quietly relied upon across multiple theatres of war. The operational problem that forced the invention of the heat rack was visibility. Open fires betrayed positions instantly. Smoke drifted, flames flickered, and even well-shielded stoves produced telltale signs detectable by patrols or aircraft. In static defences, observation posts and forward positions, heat was needed, but, fire was forbidden. Commanders demanded solutions that generated warmth and usable heat without ignition. The heat rack answered that demand by exploiting stored heat, conduction, and controlled chemical reactions rather than combustion. The core idea behind the World War II heat rack was simple but precise. Instead of creating heat at the moment of cooking, heat was captured, stored, and released slowly in a controlled way. One common form involved a metal rack or frame mounted above an already warm but concealed heat source, such as an enclosed engine compartment, exhaust duct, or insulated stove core that never produced visible flame. Armoured units used this method extensively. Tanks, trucks, and half-tracks generated enormous amounts of waste heat. Crews learned quickly that engine blocks, exhaust manifolds, and radiator housings could be used as cooking platforms once the vehicle was stationary. Purpose-built racks were welded or bolted into place to hold mess tins securely. A can of stew or a ration tin placed on a heat rack above an engine could be brought up to eating temperature without lighting a single match. Infantry units, they adapted the same logic, but using earth and metal instead. Field manuals, they describe heating racks built right into dugouts or bunkers where a small, fully enclosed heat source, such as a charcoal core or an insulated stove brick, was sealed behind layers of earth. The rack sat above the heat mass, not the flame. Once heated, the mass radiated warmth for hours. Food placed on the rack warmed slowly, silently, and invisibly. Chemical heating also played a role. Flameless ration heaters, using magnesium or similar reactions, were introduced later in the war. These produced heat through chemical reaction with water rather than fire. Soldiers often placed these heaters beneath improvised racks made from wire or scrap metal, allowing multiple items to be warmed at once. The rack kept food out of direct contact with the reaction, preventing scorching and spreading heat evenly. What made the heat rack effective was patience and discipline. This was not fast cooking. It was controlled warming. Meat stews thickened slowly. Bread softened without charring. Canned rations became palatable instead of frozen blocks. The absence of flame meant no flare-ups, no sparks, and no sudden heat spikes. In tactical terms, it meant eating hot food while remaining invisible. Applying this knowledge today is entirely practical for anyone interested in low-signature cooking or off-grid survival. The first principle is, well, separating heat generation from food contact. Instead of placing food directly over fire, you should use a heat source that is shielded and enclosed. This could be, for example, a small rocket stove buried under soil, a heated stone mass, or even waste heat from engines or generators. The second principle is using mass to store heat. Stones, bricks, or thick metal plates can absorb heat and then release it slowly over time. Once heated, these materials can warm food for long periods without additional fuel. A modern equivalent would be heating a cast iron plate or steel block and placing a rack above it inside an insulated enclosure. The third principle is controlling airflow. World War II heat racks worked because oxygen was limited. Fire was either absent or, fully contained. By restricting airflow, combustion was minimized or even eliminated, yet the heat still remained usable. In practice, this means sealing gaps, insulating the walls, and allowing only minimal ventilation for safety. Construction of a simple heat rack today can follow the same logic. A metal grate or rack is positioned above a heat mass, not a flame. Food containers are placed on the rack and, rotated periodically for even warming. Insulation around the system ensures heat stays inside. The result is silent, smokeless cooking that can operate for hours. What makes this World War II technique remarkable is not just its ingenuity, but its mindset. Soldiers and engineers treated heat as a resource to be managed, not something that had to be visibly produced. They understood that cooking did not require fire, only energy transferred at the right rate. This is the kind of historical knowledge that honestly deserves attention because it was tested under the harshest conditions imaginable. It kept men fed without giving away their position. It also conserved fuel, reduced risk, and, really improved morale. Those are lessons that, still matter. If you value serious history that translates into real-world skills, this channel exists for you. Subscribe to stay connected to research-driven content that goes beyond surface narratives, and share this episode with anyone interested in survival, fieldcraft, and the quiet engineering victories of the Second World War.